All right, we're going to bump it up a little bit. Same setup. This is going to be relative motion. We're going to call this part 2. Okay, bumping it up a little bit. We'll have the same characters come into play. We're going to have Albert. He's going to be chilling out. I'm going to do something a little bit different this time. Albert's actually going to be back here off the whiteboard. We're going to have our car driving at 2. Eventually, for reference, I'll put Marie back in the car. So Marie's going to be moving the car at 2. Here's the one little wrinkle I'm going to add. I'm going to introduce this blue sheet of paper. We can pretend that that's like water in a river, and then we'll have to use our imagination, and instead of a car, pretend it's a boat. And I'm going to add another new player into our excitement. This is Isaac. Isaac is floating on the water. So he's in the water, he's doing whatever the water does. And just for fun, just to keep the math easy, we are going to have to do a little bit of math. We're going to say that the water is moving at 1. Again, we need a unit, so even though I'm just making things up, it's not really 1 kilometer per hour, but we're going to say that the water is going to move at 1 kilometer per hour. Okay, if we think back to the last video, really what that means is I'm going to slide the paper on top of the whiteboard at a speed of 1. If we go back to our relative motion, really what that means is if I gave these guys the radar gun, Albert over here chilling out on the shore would see, Albert chilling out on the shore would see Isaac drift by at a speed of 1. Or we could flip it. If I gave the radar gun to Isaac, he could hold on to it. He would just as similarly argue that as he's moving with the paper to the right at 1, he could argue that he's actually not moving, but Albert's moving to the left at 1. So same logic as before, just instead of Marie on the car, I'm talking about Isaac on a piece of paper. The paper is going to move to the right at 1 relative to Albert. So Albert says that Isaac is moving at a speed of 1, moving to the right. Isaac could just as easily argue that he's not moving, but he sees Albert as drifting to the left at a speed of 1. That's relative motion. They each see 1, they just disagree on the direction. That's kind of a quick rehash with different numbers about what we talked about in the last video. Here's the bump up. What if I add the car? Remember, the car drives at 2. What if I add the car so that it's going to drive across the paper at a speed of 2? What I want you to think about as I set this up is who sees what? Who sees 1? Who sees 2? Does anybody see anything different? I'll run it, hopefully it works, but it should kind of look like this. Let's try that again, and as it's happening, sort of the 3 perspectives we've got is what does Isaac and the car see each other doing? What do Isaac and Albert see each other doing? And then finally the moneymaker, what does Albert and the car, what do they see each other as? Okay, one more time. Kind of looks like that. All right, so relative motion, different frames of reference. Directions become important, so we're going to spend some time talking about directions. The math is going to become important, but hopefully you can handle these numbers. If we focus on the pairing of the car and Isaac, the car was going across the paper at 2. Isaac was just hanging out on the paper. They see 2. The car could argue that Isaac's going to the left at 2. Isaac could argue that the car is going to the right at 2. They're both correct. The relative motion between those two is just the speed of the car. Because they're in the same reference frame, they're both moving on the paper. If we backtrack to the next pairing, Albert and Isaac, that didn't change when we added the car. The first part of this little blurb tried to convince you that they see each other going 1. Isaac would say that Albert's going to the left at 1. Albert could say that Isaac's going to the right at 1. They see the 1 between them. The moneymaker, if this is really working, is what Albert would say the car is doing. Or if we flipped it, what the car would say Albert's doing. Paper's moving at 1. On top of the paper, the car's moving at 2. You guys sitting at home, because the camera's not moving, you're in the same reference frame as Albert. What did it look like to you? It should have looked a bit faster. It's an addition of the velocities. They're in the same direction, so they combine to make a bigger number. Albert would argue, if he had his little radar gun, he would argue that the car is moving by at a rate of 3 kilometers per hour, happens to be going to the right. The car could just as easily argue that from its perspective, nothing's moving in the car, but Albert's moving backwards at a rate of 3. That's relative motion.